So in this problem, we have a triangle ABC. Using the law of sines, we need to show that a cubed sine b minus c plus b cubed times sine c minus a plus c cubed times sine a minus b, that's equals to 0. So what we'll do, we'll start from the left hand side. So let's note down the left hand side. In order to proceed, we'll need to find out the value of a, b and c. For that, we are going to use the law of sines. So let's say we have ABC represented by an acute angle triangle. So we have A, B, C. Also, let's specify its sides. The side BC, which is opposite to that of angle A, we're going to represent it by the lowercase letter a. Then we have side AC. This is opposite to angle B. So let's represent it by the letter B in lowercase. And then we have the side AB, which is opposite to that of angle C. So we're going to represent it by the letter C in lowercase. Then the law of sine. We have the law of sine. So that tells us that if we consider the side A and divide it by the sine of the angle opposite to it, which is side A, then this ratio will be equals to the ratio of side B to that of the sine of the angle opposite to it. So that's B. And this is also equals to the side C, the ratio of the side C to that of the sine of the angle opposite to it. So that's sine C. This is the law of sine. Now what we're going to do, we are going to suppose that let these ratios be equals to some constant lambda. In that case, we can represent A as A equals to lambda times sine A. The B value will be equals to lambda times sine B. And C value will be equals to lambda times sine C. So what we'll do, we'll replace the value of ABC with these new respective values into the left hand side. So we have A cube. So A cube will then become lambda cube multiplied to sine cubed A times sine B minus C plus B cube. So B cube will be lambda cube times sine cubed B multiplied to sine C minus A. And the third term will be become, we have C cube, so that will be lambda cubed times sine cubed C multiplied to sine A minus B. Now we are going to rewrite this expression. So we have lambda cube. Now instead of writing sine cube A, we are going to split it as sine squared A multiplied to sine A. So we have sine A multiplied to sine B minus C. Similarly, for the second term, we will rewrite sine cube B as sine squared B multiplied to sine B times sine C minus A. And on coming to the third term, we have lambda cubed multiplied to sine cube C, which will be also represented as sine squared C times sine C multiplied to sine A minus B. Now, the reason why we broke down sine squared as sine cubed A as sine squared A times sine A, now we can use the fact that in a triangle, in any triangle actually, the sum of the interior angles, we know that the sum of the interior angles of a triangle are A plus B plus C, so that sums up to pi radians. So if we want to find out A plus B, so that can be also expressed as pi minus C. Let's take the sine of the angle on both sides. So we have sine of A plus B, which will be equals to sine pi minus C. Now what's sine pi minus C? So that's simply sine C. So we can say that sine C is equivalent to sine A plus B. Similarly, we can say that sine B plus C will then be equals to sine of A. And sine C plus A will then be equals to sine B. So what we'll do, in place of the sine A, sine B and sine C in the three terms, we're going to replace it with the respective values. So let's do that. We are going to get lambda cubed times sine squared A. So this will be multiplied to sine A, but instead of sine A, we're going to use sine B plus C. We also have sine B minus C multiplied to it. Then the next term, we have lambda cubed times sine squared B multiplied to sine B. Now sine B will get replaced with sine C plus A. We also have to multiply sine C minus A to it. Coming to the third term, so we're going to get lambda cubed times sine squared C multiplied to sine C. So sine C will be replaced with sine A plus B. And we have sine A minus B multiplied to it. Now what we can do here is we can combine sine B plus C with sine B minus C. We can also combine sine c plus a with sine c minus a and sine a plus b with sine a minus b. So this will be lambda cubed times sine squared a multiplied to, so what's the product? Sine b plus c times sine b minus a. So that's simply sine squared b minus sine squared c plus lambda cubed times sine squared b multiplied to, the way of sine squared c plus a times sine c minus a, this will be sine squared c minus sine squared a. And finally we have the third term, lambda cubed times sine squared c multiplied to sine squared a minus sine squared b. Now what we can do, from each of the three terms we can take lambda cube as the common factor. We can now multiply sine squared a with sine squared b minus sine squared c. So that's going to give us sine squared a times sine squared b minus sine squared a times sine squared c plus we have sine squared b multiplied to sine squared c minus sine squared a. We will get sine squared b times sine squared c minus sine squared b times sine squared a. Then coming to the last term, we have sine squared c times sine squared a minus sine squared c times sine squared b. Right. Immediately we can observe here that sine squared a times sine squared b, so this will get cancelled out. Negative sine squared a sine squared c, so this will also get cancelled out. And we have sine squared b times sine squared c, that also cancels out, which leaves us with lambda cubed multiplied to 0. So that's equals to 0, which is the expression on the right hand side. So we can immediately say that whenever we have a triangle, acute angle triangle ABC, using the law of sine, we can prove that a cubed times sine b minus c plus b cubed times sine c minus a plus c cubed times sine a minus b, that equates to 0.